Ever wondered how software applications are tested before they reach you? Let's delve into the captivating world of software testing. Software testing, in essence, is a process that investigates the quality of software. It's like a detective story where the main character is on a quest to find any lurking bugs or defects that might affect the software's performance. This process doesn't just involve going on a bug hunting spree, but it also checks if the software behaves as expected, if it can withstand a heavy load, if it's user-friendly, and much more. Now you might be thinking, why is software testing so critical? Imagine buying a brand new car, only to discover that the brakes don't function when you're driving downhill. Scary, right? That's exactly the kind of situation software testing aims to avoid. By thoroughly examining each line of code, software testers ensure that the product you receive is of the highest quality. They act as gatekeepers, preventing any faulty software from reaching your devices. Essentially, they're the unsung heroes who ensure your apps run smoothly, your video games don't crash, and your online transactions are secure. Moreover, software testing is not a one-time activity. It's a continuous process that takes place at every stage of software development. As new features are added or changes are made, testers are there, ensuring that these modifications don't introduce new bugs or negatively impact the software's performance. In the world that's becoming more digital by the day, software testing is not just a necessity, but a priority. It's an indispensable part of the software development lifecycle, ensuring that the software is reliable, secure, and efficient. So, software testing is an integral part of software development. But how do testers ensure the software is up to par? To ensure software quality, testers follow certain principles. These principles are not just rules to abide by, they're the very heart of effective software testing, and they're what enable testers to deliver high-quality software. First up, we have the principle that exhaustive testing is not possible. As much as we'd love to test every single scenario under the sun, it's simply not feasible. There are just too many variables and combinations, and testing them all would take an astronomical amount of time. So testers have to be smart and prioritize their testing efforts, focusing on the most critical parts of the software and the most likely scenarios. Next, we have the principle of defect clustering, also known as the Pareto principle. This principle tells us that a majority of the defects are often found in a minority of the modules. In other words, bugs tend to hang out together in certain parts of the software. Knowing this, testers can focus their efforts on these bug hotspots to get the most bang for their buck. Then there's the pesticide paradox. This principle warns us that if we keep using the same tests over and over again, they'll eventually stop finding new bugs, just like pests become resistant to pesticides over time. So testers need to regularly review and revise their test cases to keep them fresh and effective. Finally, we have the principle that testing shows the presence of defects, not their absence. Even if a test passes, it doesn't necessarily mean that the software is bug-free. It just means that the test didn't find any bugs. There could still be bugs lurking in the code, waiting to be discovered. That's why it's crucial to keep testing, keep probing, and never assume that the job is done. These principles guide the testing process, but what techniques do testers use to find those elusive bugs? Let's delve into that in the next scene. Finding bugs in software is like hunting treasure. It requires specific techniques. With that in mind, let's dive into the world of software testing techniques. The first one on our list is black box testing. This technique doesn't require any knowledge of the internal workings of the software. It's like being presented with a mysterious black box and figuring out what it does based solely on its inputs and outputs. Testers create test scenarios and inputs to check if the software behaves as expected. The advantage of this technique is that it simulates the end user's interaction with the software, focusing on functionality rather than the code itself. Next up, we have white box testing. This is the polar opposite of black box testing. Here, testers need to have a thorough understanding of the software's internal structure. It's like having a clear box where you can see all the gears and cogs working together. This technique focuses on how the software works, checking the internal operations to ensure everything runs smoothly. White box testing allows testers to find hidden errors that may not be apparent during black box testing. Finally, there's a technique that combines the best of both worlds: gray box testing. This technique is a hybrid of black and white box testing. Testers have partial knowledge of the software's inner workings, allowing them to focus on broader aspects of functionality along with some internal operations. It's like having a box where you can see some of the gears and cogs but not all of them. This approach offers a more comprehensive testing strategy, providing a balance between user interaction and code-based testing. So there you have it, black box testing, white box testing, and gray box testing. These techniques are the treasure maps that guide testers in their hunt for software bugs. But remember, a treasure hunter is only as good as his tools. Armed with these techniques, testers can find bugs, but they also need the right tools to do their job effectively. Just like a carpenter needs his tools, software testers also have their own set of tools. Now let's dive into the toolbox of a software tester. The array of tools used in software testing is vast and varies based on the specific needs of a project. However, they can generally be categorized into three main types: automation tools, performance testing tools, and defect management tools. Starting with automation tools, these are designed to expedite the testing process by automating repetitive tasks. Selenium is a prime example of such a tool. It's a free, open-source testing framework that supports multiple programming languages, such as Java, Python, and C#. Selenium allows testers to write scripts in these languages to automate web browser activities, saving precious time and effort. Next, let's talk about performance testing tools. These tools are used to simulate a variety of load conditions and analyze how the system responds under stress. JMeter is a popular choice in this category. It's an open-source software designed to load test functional behavior and measure the performance of websites, databases, and more. With JMeter, testers can simulate heavy loads on a server, group of servers, network, or object to analyze overall performance under different load types. Finally, we have defect management tools. These tools help in tracking and managing defects in a software application. Bugzilla, for instance, is a well-known defect management tool. It allows testers to log issues, assign them to the right team members, and track their status until they are resolved. Bugzilla ensures that no bug slips through the cracks, contributing to the overall quality of the software. So whether it's automating repetitive tasks, stress testing a system, or tracking and managing defects, each tool in a tester's arsenal plays a crucial role in the software testing process. With these tools, testers can efficiently find and manage bugs, ensuring the software you use is of the highest quality. So we've learned that software testing is a vast and complex field. It's a universe unto itself, full of intricate principles, techniques, and tools, all dedicated to ensuring that the software we use daily is of the highest quality. Let's take a moment to recap. We started with the principles of software testing. These are the guiding lights that shape the approach to testing any software. We discussed the concepts of exhaustiveness, defect clustering, early testing, and the pesticide paradox, among others. These principles help testers identify potential problem areas, prioritize their efforts, and approach testing in a strategic and effective manner. Then, we dove into the techniques of software testing. We learned about the black box, white box, and gray box testing, manual versus automated testing, and functional versus non-functional testing. Each of these techniques has its unique strengths and uses, and together they form a comprehensive testing strategy to ensure the software's functionality, usability, performance, and security. Next, we explored the tools for software testing. From unit testing tools like Junit and Nunit, to performance testing tools like LoadRunner and JMeter, each tool serves a specific purpose in the software testing process. These tools help testers automate repetitive tasks, manage testing activities, and generate useful reports, making the testing process more efficient and effective. But why does all this matter? Because software testing is not just about finding bugs, it's about ensuring the quality of software products. It's about making sure that the apps and software we use are reliable, secure, and user-friendly. It's about building trust between users and software developers. So, the next time you use an app or software, remember, a lot of testing has gone into making it work seamlessly for you. Each click, each swipe, each function has been scrutinized, tested, and retested, all with the aim of providing you with a smooth and enjoyable user experience. Software testing is the unsung hero of the tech world, working quietly behind the scenes to make our digital lives easier and better. Next time you use an app or software, remember, a lot of testing has gone into making it work seamlessly for you.